This video is for section 4.3 from Math 95, Systems of Linear Equations and Problem Solving. Our goals for this section are to solve some different kinds of problems that can be modeled with a system of linear equations and to solve some problems involving cost and revenue functions. What that means is we're going to be looking at story problems. Now in these types of problems, it's really important to understand what your variables are, to define your variables. Usually, you'll define your variables and then write down a couple of equations that relate those variables. Now sometimes you might find that you can write down an equation and then go back and write down what the variables are. Whichever order you do it in, it's really important that somewhere you write down what the variables are supposed to represent. This is really important for a couple of reasons. One reason is that it clarifies your thinking and makes the problem clear. It saves you so that when you get to the end of the problem, you know what that x was supposed to be. The other reason is that it communicates to anybody else who reads your work, whether that's your own future self, your co-workers, your study buddies, your lab partners, what the variables are supposed to be. It communicates your thinking to the other people who you work with. So defining variables is really important. For most of these problems, you're going to find that you have two variables and two equations. That makes a system of equations just like the kinds of problems that you were solving back in section 4.1. Finally, when you answer the questions, you should be able to answer in a complete sentence that includes units. Part of this is to check for reasonableness. You want to be able to say your answer and have it make sense. All right, now that we've got a little background, let's do a few of these problems. Our first problem is an example of a break-even problem. It says, Tree Trunks finds that it costs her $12 to make an apple pie plus $15,000 of overhead. She can sell each pie for $32. That means that her cost and revenue functions are the two functions shown below. How many apple pies does she need to sell to break even? Before we dive into this problem, let's just look at what these two functions represent. The first function is the cost function. Remember, it took her $12 to make each apple pie, plus she has $15,000 of overhead. For the revenue, that's how much money she can make. It's $32 for each apple pie. So what does X represent here? Hopefully, you've realized that X must represent the number of apple pies that Tree Trunks makes. So it's the number of apple pies. Our question asks us, how many apple pies does Tree Trunks need to sell in order to break even? Breaking even is when your cost and your revenue are the same. The amount that it costs you to produce something is the same as the amount of money you get for selling it. So overall, you're not making any money, but you're also not losing any money in the production. That's what the break-even point is. So since the break-even point is when cost and revenue are equal, all we need to do is set the cost and revenue equal to each other and then solve for the number of pies. That looks like this. The cost, my 12x plus 15,000, needs to be equal to my revenue, which is 32x. Now I've got one nice equation that I can solve for x. So I'm going to go ahead and subtract the 12x to the other side, which gives me 15,000 equals 20x. Then I'll divide both sides by 20, which will tell me that x equals 750. Now, this seems like a pretty nice answer, but we're not really quite done yet. We should really write down our answer as a sentence. So I need to remember what that x represented again. X represented the number of apple pies. This is another time when you can see that those variable definitions are really important. It doesn't help Tree Trunks at all if I tell her, well, your break-even point is x equals 750. She really needs to know what that 750 represents. What is it? So for Tree Trunks, her break-even point is 750 apple pies. She needs to make and sell 750 apple pies in order to break even. So again, she needs to make and sell 750 apple pies in order to break even. Our next problem is an example of two types of objects problems. Finn and Jake are putting on a show. They sell 54 tickets for a total of $318, but they don't remember how many of each type of ticket they sold. Adult tickets cost $6.50 and children's tickets cost $5. How many of each type were sold? Now, before we can start answering this question, we need to figure out what our answer ought to be, what we're looking for. This question is asking us for how many of each type of ticket. That tells me what my two variables are going to be. One of my variables will be the number of adult tickets, and the other variable will be the number of children's tickets. If I can find out those two things, the number of adult tickets and the number of children's tickets, then I'll be able to answer the question, how many of each type were sold. So there's my two variables. The next thing to do is to start trying to write down some equations. So let's read through the problem and see what we know. They sell 54 tickets. Well, that gives me some information right there. If they sell 54 tickets altogether, that means that the number of adult tickets plus the number of children's tickets needs to equal 54. In equation terms, x plus y is 54. Now we'll go looking for any other information we have that could lead to a second equation. We haven't used the fact that the total amount of money that they made was $318. So let's see if we can get something to equal that total amount of money. Since the adult tickets cost $6.50, if we write down $6.50 times x, that'll give us the total amount of money that they get from the adult tickets, plus 5 times y, that'll be the total amount of money that they get from the kids' tickets, and that should equal the total amount of money that they make. Now we have two equations and two variables. This is a system of equations, so we should be able to solve it. I'm going to go ahead and solve this system of equations using substitution. Here I have x plus y equals 54. It would be pretty easy to solve this equation for either x or y. I'm going to solve it for y. So I'll subtract x from both sides and get y equals 54 minus x. Now I'm going to take that and substitute 54 minus x for y over in the second equation. That gives me the equation 650x plus 5 times 54 minus x equals 318. Now I can solve this equation for x. Remember that x is the number of adult tickets. So 650x, 5 times 54, this gives me 270 minus 5x equals 318. Then I will subtract 270 from both sides, and I'm also going to combine these two x's. I'm kind of doing two steps at once now, so either pay close attention or make sure that you feel comfortable with it. Remember, you can go back and watch it again. The 650x minus the 5x gives me 150x, and then on the right hand side I'm subtracting 270, so that gives me 48. And 48 divided by 150 gives me that x equals 32. Now remember, x was the number of children's tickets, or of adult tickets, and I still want to know the number of children's tickets. Fortunately, we have two equations that can do that for us. I'll take the x equals 32 and plug it back in to either one of these equations and then solve for y. I'm going to pick the first equation since it looks like the easiest to me. So I take x plus y equals 54, and I replace the x with 32. So 32 plus y equals 54. Subtract 32 from both sides, and y equals 22. So that means that they sold 32 adult tickets and 22 children's tickets. Our next problem is a mixture type problem. It says, Princess Bubblegum needs 12 liters of a 30% sugar solution for an experiment. She has one solution that is 20% sugar and another that is 50% sugar. How many liters of each mixture should she combine to get 12 liters of a 30% sugar solution? Once again, I'm going to start by defining our variables. The question asks, how many liters of each mixture should she mix? So my answer is going to be something like she needs 100 liters of the 20% solution and 12 liters of the 50% solution. Of course, 112 won't work very well. So my variables will be something like x equals the number of liters of the 20% solution, and y equals the number of liters of the 50% solution. Now that I have my two variables, it's time to start trying to come up with some equations. Now, in the end, Princess Bubblegum needs 12 liters total. So however many liters of the 20% solution and however many liters of the 50% solution I mix together, I need to get 12 liters total. So that means that one of my equations must be x plus y equals 12. Coming up with the second equation will be a little bit more tricky. I'm going to show you the way that I like to think about these problems. But there are lots of other ways that you can think about these problems and wind up with the same equation. So find the way that works best for you. What I want to do is think about how much actual sugar is being combined in each part. So let's say that this over here is my liter or vial that contains the 20% solution. And this over here contains the 50% solution. I'm going to pour them together, and I want to end up with 12 liters of a 30% sugar solution. Now, how much sugar is actually going to be in that whole 12 liters? If only 30% of it is sugar, that means that 0.3 times 12, which equals 3.6, there will be 3.6 liters of sugar, and the rest of it will be whatever the sugar is dissolved in. So in here we can see that we'll have 3.6 liters of sugar, and then other stuff that adds up to a total of 12 liters. We can do the same thing to the left side of our little visual equation here. If this one was my bottle of 20% solution, then however much I mix together is going to be a total of x liters. But not all of it is sugar. Only 20% of it is sugar. So the part of it that's sugar is 0.2 times x, and the rest of it is filler. With my 50% solution, though, however much I mix together of it is y, since that's how I defined it, and half of it, 50%, will actually be sugar. So this will be 0.5 times y, 50% of the number of liters, and the rest of it is filler. This points to my other equation. The amount of sugar that I add together from these two needs to equal the amount of sugar in the final product. So 20% of the 20% solution plus 50% of the 50% solution needs to equal 30% of 12, or 3.6 liters. And now we've made it through the tricky part. We have two equations, and we have our two variables. Now we just need to solve it. I'm going to solve this equation by substitution again, because it looks so easy to do that way. I've got x plus y equals 12, so I can solve this little equation for either x or y. Since I did y last time, I think I'm going to do x this time. Right, so I'm going to solve this equation for x. X equals 12 minus y. Then I'm going to take that 12 minus y and plug it into my second equation over here. So that gives me 0.2 times 12 minus y plus 0.5y equals 3.6. Now I just need to distribute that 0.2, and we'll see what happens. 0.2 times 12 is 2.4, and then minus 0.2y plus 0.5y equals 3.6. We'll combine the like terms, the y values there, to get 2.4 plus 0.3y equals 3.6. Now I'll subtract 2.4 from both sides, which gives me 0.3y equals 1.2. Divide both sides by 0.3, and y equals 4. So that means that we need 4 liters of the 50% solution. Now we can go back, use the fact that y equals 4 to find out what x is. Remember, x is 12 minus y, which makes sense since we want 12 liters total, and we know that 4 of the liters need to be the 50% solution. So x is 12 minus 4, or x is 8. So our final answer is that she needs 4 liters of the 50% solution and 8 liters of the 20% solution. So this video had an example of a break-even problem, a multiple kinds of things problem, and a mixture type problem. Most of the problems in your homework should be those kinds of problems. So, happy studying!